So, you want to learn how to TIG weld, but all the TIG welding videos are just information overload. Do I need thoriated tungsten or serrated tungsten? How many gigawatts do I set the flux capacitor to weld 1/8" steel? I know, I've been there too. I'm Rob, this is Venturi Fab, and today we're going to simplify it so that you can start welding. This is TIG 101, a crash course in TIG welding. We're going to cover just the basics of what you need to get started so that you can actually start applying it and learning, and not just information dumping on you a bunch of stuff that you just don't need at the beginning. As with all of the 101 videos on my channel, this video is going to be cleanly broken down into chapters, from everything from the protective equipment that you're going to need, like welding hoods and gloves and stuff, to how to set your torch up, to how to set your welder up, and then we're going to roll right into how to weld. I've got a very simplified way of how I teach people to weld at the very beginning. So hopefully if you've been, kind of struggling from what you've picked up from other videos, maybe my approach will be that last little piece that kind of makes it all click for you. So, without further ado, let's get into it. So the first thing we need to talk about is PPE, right? You need to protect your eyes and your skin from both the ultraviolet rays that are going to come off your weld and also from the heat. So you're going to want a good pair of gloves. I recommend thin gloves for TIG welding. You're going to need to feed your fill rod as you're welding. And so if you don't have gloves that have good dexterity and good feel in them, you can't feel this thin rod, and it's a lot harder to feed it into your weld. So good thin leather gloves. I recommend the Tillman 1488s. These are my go-to. Another thing that's nice to have is called a TIG finger. So your hand that's holding the torch, you're close to your heat source, right? You're right up on your weld for the most part. And this just gives you an extra layer of heat protection, because as much as you need the dexterity of thinner gloves, they don't provide as much heat protection as like thicker MIG or stick welding gloves, right? So you use something like this, which is a fiberglass little sheath for your finger, or you can just use it as a pad to rest your hand on. Gives you that extra heat protection right up close so that you don't cook your hand while you're welding. The other two really important things that you need, as with everything in a shop, safety glasses. Lord only gave you one pair of eyes, so you need to protect them. And the same logic goes into your welding helmet. You're gonna need a welding hood, right? You can't squint and weld. You need to protect your eyes with the proper welding hood. You don't need a $500 Viking 3350 to weld. What I would steer clear of with welding hoods are like your bargain basement no-name brands. Your XYZ welding or whatever on Amazon. Stick with a brand that's kind of a known brand, right? Like Jackson is a known welding brand, and this helmet's not ultra expensive. What is this? This is a Oh, duh, it's right there. This is a W40 Insight. You don't have to get that one, but the Vulcan welding hoods at Harbor Freight, I've heard a lot of really good things about those. Those are like on sale pretty regularly in that $120 price range. As much as you don't need a top of the line hood, like, do not go cheap. These are your eyes that you're talking about. So the really cheap hoods are going to have really cheap electronics, which means they're not going to switch to darkening as fast as a better hood with better electronics, right? And it doesn't sound like much, but that fraction of a second when you're practicing is all that extra strain on your eyes, and it will wear down your eyes. I've had that happen using cheap hoods before. There's been times when I needed to use just whatever hood was laying around, and you can feel the difference in your eyes. So make sure you get at least a half decent hood. I think you know, the difference in quality between like a $50 hood and like a $120 hood is a big quality difference, right? Like between your bargain basement Amazon hood and say like a Harbor Freight Vulcan hood. There's a big quality difference there. I think that once you kind of get above that medium point, as with a lot of things, with cars and tools and everything, that cheap to middle price point, big quality increase. The middle to high end is not as big of a bang for your buck deal. So, like I said, at least get something in the middle. By all means, if you want to throw down on a really nice welding hood, 1000% worth it, but you don't need it. The second thing on this list is it's kind of a mindset thing. You want to go into this with realistic expectations, right? You're learning a new skill. You know, and all of us look at, you know, you see DimeStackerKing on Instagram or whatever, and they're laying down all these beautiful welds. But DimeStackerKing wasn't always DimeStackerKing, right? He used to be Tungsten Dipper King. And then over years of repetition and practice, you gain that skill to be at the high level. So don't judge your day one or week one or year one against some professionals year 10 or 15. You know what I mean? You're gonna dip your tungsten. You're gonna dip it a lot. You're going to make welds that are really ugly. You're gonna weld too shallow. You're gonna weld too hot and blow holes in things. It's all a learning process. So don't get discouraged when you blow a hole in a weld, or, you know, you weld a fillet joint and you go, like you're practicing, and you go test it and it snaps right off. That's all part of the process. Every single one of us has been through that stage. Every single one of us. I still dip tungsten. Like, it's part of the game. You know what I mean? It's what happens. So, like I said, don't compare your day one to someone's day 1000. Just approach it with a good mindset, and as long as you believe in your ability to learn this stuff, you 1000% can learn how to TIG weld. All right, next we're going to go over the parts of a torch and how to set it up properly. Especially for learning, just use the torch that your machine came with. Most likely, it came with this. This is a number 17 torch. This is the medium size. This is a number 9 torch. This is smaller. See, like the body itself is very similar, but the head, where everything goes, is smaller than the head on the 17. So the smaller your head is, right, the smaller your torch is, the less amperage that it's rated for. Most TIG welders come with a 17. That seems to be the common go-to. So for what we're doing, this is going to be just fine. You don't need fancy big cup consumables that cost a couple $100. You don't need any of that. You just need the basics that your torch came with. So this is your fully assembled torch. You have your cup. This directs the flow of the gas. You have your back cap. That's what your tungsten goes into through this, right? Then you have collet body and your collet. So the way this goes inside of this, your tungsten slides through the hole. These are sized by the size of your tungsten. There's several different sizes of tungsten. They're all better for certain things. Get 330 seconds. 330 seconds is fine for thin metal. It's fine for thick metal. It's the most universal all-around tungsten. It'll arc good at low amperage for like sheet metal. It'll arc good at high amperage for thicker metal. It's kind of just if you could only have one size tungsten, 330 seconds is what you want. So that's what you should get. Then you don't need to get a ton of it. You don't need every size for every situation. So that'll go through there. You can see there's that hole there. So you size that to your tungsten. Your collet You can see it's got these slits in it, so when you tighten everything down, it squeezes those slits and locks your tungsten into place. So that's inside your torch like that. There it is. And these guys, I think they're called insulators. It's just like a little heat shield to keep everything separate. So your collet body will go screw on, and these smaller torches go together exactly the same, just the parts are smaller. So that would go into here. Your cup goes onto that. And for what we're welding, we're just going to be covering steel today because that's all you need to get started and you don't need any special stuff for it. You want around a number 8 cup, which means 8/16ths of an inch. Each one of these number is that many 16ths of an inch in the opening of your cup. A number 8 is half an inch. This is a number 7. This is just 1/16 smaller than that. For what we're doing, if your torch doesn't come with a number 8, but it's got a number 7 or a number 9, those will be just fine too. So your collet will go inside there. Your tungsten will go in. And then your cap goes into the back and tightens everything. For the amount of tungsten that you want sticking out, you want it to stick out as big as the cup is, right? So this is 7/16ths of an inch. So you want your stick out to be about 7/16ths of an inch. A little bit more or a little bit less is fine. To make that super simple for you, you can get these little machined aluminum blocks, and they've got numbers on them that correlate to a cup size, and these holes are drilled to the correct depth for that number. So we can take our torch. This is a number 7. Here's the number 7 spot. Put it in there, set the torch down, tighten the back cap to lock everything in, and now you have 7/16ths of an inch stick out. These are a really great tool, especially early on, because it'll help calibrate your eye to this is the appropriate stick out for this setup. And it'll have for the various different numbers on there. So it's a great learning tool for that. And then you're getting a consistent setup, which, especially when you're learning something, right? The more consistent you can make everything, the better you're going to learn because you have less variables that are changing, right? So if your stick out is the same every single time, you can learn around that. And so you know this part is correct. The next common thing that just gets, it's an information overload topic is which tungsten do you use? Because there's like 20 different kinds of tungsten. It's pretty simple, especially when you're starting. You're not really going to be able to tell the difference between the different tungstens. So if you have an older welder, like a transformer welder, and you'll know it's a transformer welder because it's freaking huge. Those are the big old welders. They're picky about what kind of tungsten you use. So we're only worrying about steel right now, so we don't need to worry about all these different options and all that. Just get like red or blue, okay? Red or blue tungsten in a big transformer machine will be just fine for steel. It's not going to be ideal for like aluminum, but for steel, perfect. And that's what we're dealing with now. So transformer machine, get red or blue. If it's if it's an inverter machine, so if it's a newer welder, right, and it's a more compact size TIG welder, they don't really care what you put in them. I typically use this like chartreuse color. This is called Laser by CK. I've used the purple E3 mix. I've used red and blue and gray. They don't care. Just get 3/32 so that you're well-rounded to do anything. And for an inverter machine, get whatever color you want. But this laser, the chartreuse color, this is my personal favorite. This is what I use the most right now. And then real quick, since I had this one on the table, functionally, these two torches are exactly the same. The only difference is this one's got this little knob and you can adjust the angle, which doesn't matter for learning, but as you progress down this road, if you get to where you're doing like a lot of tube or roll cages or anything like that, that adjustability is kind of nice. However, you don't need it for this. All right, next we're going to talk about setting up your welder. So some general rule of thumbs here. If your welder has pulse settings, for now, ignore them, turn them off. That's not relevant. The only ones that are going to matter right now are your main amps and your post flow, if it has an adjustable post flow. If it doesn't have adjustable post flow, it is what it is. If it does have an adjustable post flow, to start, just set it for 5 seconds. And then when you start welding, we'll see what it does, right? You want to set it to where your post flowing just a touch longer than your weld is still glowing. So if it's still glowing at 5 seconds, your post flow needs to be a little bit longer. If it's only glowing for 2 seconds, you can set your post flow to like 3 seconds. And that will vary depending on the thickness of the metal that you're welding, right? If you're welding a lot hotter, it's going to stay hotter longer. If you're welding something thin and cooler, it's going to cool down faster. The only other one that you need to adjust to start is your main welding amps. The general rule of thumb is 1 amp per thousandths of thickness. So if you're welding 1/8 steel is 0.125 inches thick, which is 125 thousandths, 125 thousandths, whatever. You know what I mean. So you're going to want to set your machine to 125. If you're welding like 18 gauge steel, which is pretty standard sheet metal steel for a car, those are, I believe, 0.00 or they're 0.0475 thick, right around there. So just under 50 amps. And what I recommend doing, there's a lot of people that'll say like, oh, I just set my welder to the max and then I do everything with my foot. I get where they're going with that. Here's the problem with that. The way your foot pedal works is all the way up is off. All the way down is whatever your max amperage is set to. So if you need to be welding at 50-ish amps and your pedal is set to 200 amps, the only part of your pedal that you can use and adjust is that first quarter. So your pedal is going to be a lot more jumpy because you're not going to have very much fine tuning to it. You're only going to have that top little bit of the pedal. Otherwise, you're blowing through everything. If you set it to, like say we're doing 1/8 steel, right? And you set this exactly to 125. At that point, you're going to be floored all the time and you're not going to have any adjustability in your foot whatsoever. So what I recommend you do, and this is how I set my welder up and how I've set it up for years, is you go, like let's say you need 125, right? We're welding 1/8 steel. You should be right around 125 amps. So go to 125 and then add like 10 or 15 more amps to that. So that way, if you're full pedal, you've got a little bit extra to either get your pedal started a little bit quicker, or if your material's cold and you just need a little bit more heat to get it to do what it needs to do. And that way, you're welding at about, 2/3, 3/4 of your pedal. And that way you still have some featherability. You can go a little bit cooler, you can go a little bit hotter, as the metal calls for. As you're watching your pedal and you see like, oh, I need to get this a little bit hotter. Oh, I need to get this a little bit cooler. You still have that adjustment in your pedal, but you're not dialed so far out here that your pedal's finicky because your adjustment range is only a little portion of the pedal. The one last setting with your welder is going to be your gas flow. The rule of thumb for your gas flow is whatever size your torch is. So for us, we're going to be using this number 17 torch with a number 7 cup. So your gas flow needs to be in the range of this number times 2 to this number times 2.5. So I want my gas flow with this setup to be somewhere between 14 and, what would that be, 17 or 18, 17 and a half, something like that. So I want to be right about, 15, 16 CFH on that, so that I'm right in between the lower end of the spectrum and the higher end of the spectrum. If your flow is too low, then you're not going to have enough gas coming out of your torch to properly displace the oxygen around your weld. If your flow on your regulator is too high, your gas is coming out of here at too high of a velocity, and it swirls and mixes in with all the air around it, and so it pulls a bunch of the surrounding air into your puddle. Therefore, your argon isn't displacing the air there, it's just mixing in with it. So now we're going to get everything set up and turned on. With your tungsten, like I said, if you've got the inverter machine, you can run any color you want. I use this chartreuse laser tungsten. You can see how the end of that is, come on, a point, right? Right now, we're not going to worry about if your point is super long and pointy or if it's stubby and pointy. Just know that what this is, your electricity is going to come off that and it's going to reflect off the other side. So if you have a stubby pointy one, you're going to have a stubby cone and a fatter puddle. If you have a longer pointy one, you're going to have a longer taper and a little bit narrower of a puddle. Right now, it's really not that important. It's not going to affect your ability to start and learning how to do this. This is something that we can delve into later as you build your skill, but it's not that important right out of the gate. What is important is getting this thing to a point. So there's a lot of different ways to do that. You can invest in a tungsten grinder, which is like a little Dremel that you spin it in. Here, I got one. So it's like I said, it's like a Dremel with a head on it. It's got a diamond blade. It'll have different sizes that the tungsten fits into, and then you put it in there while it's spinning. You spin your tungsten by hand. It grinds it into a point. I sharpen mine on a bench grinder. I have a little dedicated bench grinder that I only use for sharpening tungsten. And you don't need to do that either. What you can do, especially when you're starting out, we've all got angle grinders, right? Put a flap wheel on it. It's going to spin. You want to go with the spin so that it's spinning past it like that, right?
And you can turn it on, hold it, and just make sure that as you're doing that,
you're rolling the tungsten in your hand, or you could hook this up to like a cordless drill and do it. But you can sharpen your tungsten with an angle grinder. Don't use a dirty pad or a dirty flap wheel or a dirty grinding disc that's been cutting through all kinds of different stuff. You want to keep your tungsten stuff just to doing your tungsten. Otherwise, it's going to embed like your little bits of steel or little bits of aluminum or whatever you've been cutting. It'll embed that into this, and you don't want that. So my method here is very similar in process to how you teach someone to drive a manual transmission, right? If you try to teach clutch control, brake, gas, everything all at once, it's too much and you just stall out. So we're going to focus on one skill at a time. The very first part, we're going to get everything clean and ready to weld. Then we're going to work on just using the pedal, just getting a puddle started and moving that puddle without dipping your tungsten. Then, once we can do that, we'll worry about adding filler in. But we're not going to try to do everything all at once. So, the deal with TIG is everything needs to be clean. TIG is not like stick welding or flux welding or anything like that, where you can just like blow through all this mill scale, it won't weld it. So it'll spatter, it won't want to puddle right, it's nasty, you're just going to be fighting yourself. So we are going to buzz this mill scale off with a flap wheel on our grinder. And then the big deal with cleanliness here is we're going to wipe everything down with acetone. One thing you're going to want to invest in is acetone. Just get like the gallon jug of it from Home Depot or Lowe's or wherever. Don't even bother getting a little tiny bottle because you're going to blow through it super fast. You use it for everything because everything needs to be good and clean. So let's get these two pieces prepped, and then we're going to start working on that control. Shows up on the camera. So here's your mill scale. This is not weldable. This is lightly scuffed. You can see how it's kind of still kind of dull. This isn't going to weld that great either. What you want to bring it to is a condition called bright metal. See how that's shiny? It's shiny clean. That's the condition that you want it to be in for TIG welding, because basically what you're doing with welding is you're sending electricity to ground. So just like if you're grounding like your car stereo or anything like that, the better your ground is, the better it's going to conduct that electricity, hence the better it's going to weld. That's basically what we're doing when we clean this, is we're creating a super clean ground. That's why, like, if you dip your tungsten and you get like a little bit of your puddle on here or some filler on your tungsten, it starts making your puddle all erratic, or it won't want to puddle, or it'll shoot it sideways, and that's the same reason. You're affecting its ability to shoot into ground. So then we'll take our acetone on a clean towel, wipe that down. We're going to get our filler. You also want to wipe your filler down. So we'll go to the clean side of this rag. Let's see if that shows up on the camera, but all those little brown lines, that was stuff that's on your filler, and that's also going to make it not weld that good. So cleanliness is the name of the game here. Okay, so I was editing this and I realized that I kind of glossed over something that's kind of important. You're a welder. You're going to have a negative and a positive. This one is for your torch control. This one's for my gas. Depending on your welder, some of them do the gas through your torch lead. This is the torch lead with the red, or with the red hose. And some of them have the gas externally, and it's like a little jumper hose like this. For 99% of what you're going to weld, your torch lead is going to go to the negative terminal. See? And your ground is going to go to the positive. This is called DC electrode negative, because your electrode, which is the tungsten in your torch, is negative. Yeah. Further down the road, when you get to like learning how to do aluminum stuff, these still stay the same. Your machine, when you set it on AC, takes care of the switching. You don't need to change your torch leads. For most people, your torch leads are never going to leave this configuration. Ground to your torch, positive to your ground clamp. The other thing that I noticed is this little system that I rigged up to try to capture arc shots failed miserably. You can't see anything in it at all. So, number one, I need to figure out something better for that. Number two, the explanation's still really good. I still show a lot of good examples. So hopefully you can still get what I'm trying to get across to you to help you get started welding it. But as for actual, like, really nice, clean arc shots, I still need to figure out a better way to capture those. So, let's get back to the show. So, the thing that a lot of people talk about is like your torch height. You just want to be, especially to start, you don't want to be touching. You want to be maybe a 16th-ish away. And the wider, you'll be able to see that there's like a sweet spot, right? If you get too close, you're going to touch it. If you start pulling far away, your arc's going to start wandering all crazy. So you're going to find that sweet spot. And you want to be, in a perfect world, you would be perfectly vertical, but you also need to be able to see. So you don't want to be sideways like this, but you can't see if you're perfectly vertical. So you're going to, be a couple degrees back so that you can see. So what we're going to do, I'm right in my pedal here. We're just going to do a couple little pedals. So we're set at 135, which is 10 above what this needs by the general rule of thumb. And let's make a couple pedals. See all that spittering and spattering? Is this flowing? Hey, this is not flowing any gas. So that's what happens when you don't have any gas. Alright, well, something is wrong with that torch, and I don't really have the time to mess with it right now. So we're going to use my normal torch, which now we need to adjust the gas flow up a little bit because this is a number 8 cup. So we want to be 16 to 20. There you go. For whatever reason, that other torch is, the gas line is clogged on it somewhere. I haven't had it on my welder in a couple of years, so who knows what's going on with that gas line. We're not going to sit there and mess with that right now. So let's re-wipe everything real quick because it's been sitting here. Make sure everything's good and clean. But you saw those sparks, how it sparks out like that. That's either something in the metal that's reacting and spitting out, or you don't have gas coverage. But at the end of the day, when it sparks and spits like that, it's some sort of contamination. But let's try this again. About a 16th up. We're just going to make a couple puddles like that. I'm going to try holding this at an angle that you guys can see in this camera. So right now my pedals are a little teardrop shaped, and that's because I'm holding this at a little bit extra of an angle because I'm trying to make it so that this camera can see what's going on. Like I said, I don't have the best setup for arc shots, but I'm making do with what I can. So we'll show you the difference here. I'm going to put it a little bit more extra. I'm going to put it a little bit more extra sideways again so that hopefully this camera can pick it up and see. But you're going to see the puddle start really small and it's going to grow. And this is a really good exercise to do because as you push the pedal down more and more and more, right, you're feeding it more and more amperage towards the max that you have it set at. And so it's going to start growing that pedal. The more amperage is the more heat, the bigger the pedal. So when you're just like, maybe we'll start at like a third of the pedal and you can see it's a little puddle, and then it'll get bigger. So we're right there. Now it's starting to puddle and we're at, I can't see that, about 45 amps. So then we can roll into it. And you can see it getting bigger and bigger and bigger as we put more and more heat into it. You can see how too, when we put all that extra heat into it, how much longer that pedal glowed. So we're right there. Now it's starting to pedal. And we're at, I can't see that, about 45 amps. Then we can roll into it, and you can see it getting bigger and bigger and bigger as we put more and more heat into it. So what we're going to do now as our exercise, right? We've made some pedals. You can see the relationship to your foot pedal and how big the pedal's getting. So what we're going to try to do now is just drag a little line. So we're going to try to keep our torch height consistent. So our goal with doing this right now is to maybe start here and move, you know, an inch or two and keep the pedal width consistent all the way across. There's our pedal, and we want to keep that consistent as we move across. So if your torque height changes while you're doing this, it'll change your pedal consistency. If your foot starts putting a bunch more power into it, that'll change your pedal consistency. Let's see how we did. There you go. So you see how that's pretty uniform? That's consistent torch height and consistent pedal. So if you push down more on the pedal and give it more heat, it'll get wider like that. If you pull your torch further away, but your foot's staying the same, it'll also widen out like that because it's giving the arc more room to weld or to spread out. So what we'll do now is, this is a skill you want to practice, and I honestly, a lot of people aren't going to tell you to do this. I think from the very beginning, as soon as you're fairly comfortable doing this with your dominant hand, switch hands and try doing it with your other hand. It's going to be a lot harder. It's not going to look good at all. But I find myself in situations fairly regularly, actually, where I at least need to like tack things together with my offhand. Part of that is, as you've heard from me in some of my other videos and stuff, I have my eye issue from when I was younger. And so I can't really see the best sometimes, depending on where I am in something. So I kind of have to make do with what I've got. And I know it's something that's saved my butt a whole bunch of times. I'm super out of practice with it right now, so this is probably going to look like hot garbage. But we're going to do a bead like that. I'm going to try to match about the same size and do an opposing bead, but left-handed this time. So let's try left-handed. Got a pedal. And keep everything good and consistent. Let's see how we did there. Could be a little straighter, but for being out of practice, it's not too bad. It's definitely something I need to practice a little bit more. Got a pedal. And keep everything good and consistent. So we'll do some pulling off. Obviously, well, not obviously. So if you dip your tungsten, we'll dip it in a second. If you don't see that you dipped it, I don't know if it'll show up on this camera, but the colors of everything is going to change. The color of your arc will change. So we're going to do a pull off first, so you can see what happens as it gets too far away. And then we'll dip it and you can see the color change. And then we'll start adding filler in. So there's good height. And then as you pull it away, you can see the puddle dancing around a whole lot more and getting wider, and it's kind of like spinning. I don't know if, hopefully that camera's catching it. I'm actually kind of surprised that it's still holding the puddle down there. See, now it's spitting. So we got too far away for the gas tubing. I'm actually really surprised that that held the puddle out that far. And then as you pull it away, you can see the puddle dancing around a whole lot more and getting wider, and it's kind of like spinning. I don't know if, hopefully that camera's catching it. I'm actually kind of surprised that it's still holding the puddle down there. See, now it's spitting. So we got too far away, but you can see inside there all that porosity. That's what happens when it sucks all the actual normal air in, is it reacts with it, and that gets all that spitting and nastiness. And what happens too when it spits like that is it'll spit onto your tungsten, which you can see there's a little bit of it right there. I don't know if it shows up on the camera or not, but you could, hopefully it shows up on the camera, but you can kind of see like your arc getting all weird and big and crazy, and you want to be close enough that it's nice and tight, but you're not touching it. So now we're going to make a puddle, and I'll dip into it, and hopefully these cameras will pick up the color change, but that's how I can always tell too. If I don't catch it necessarily with my eye, like it's a light dip, the shades of the colors, even through your lens on your hood, will change. And if your color changes, you got to resharpen it because you need that clean electrical path. So here we are. We're going, and dip. And it sticks. We'll keep welding with it. You can see how the color of the arc is changing as this tungsten becomes more contaminated. And so here now we got our tungsten getting contaminated. And you see as I pull off, I haven't pulled off nearly as far. And this arc is doing all kinds of crazy stuff. So here we are. We're going, and dip. And it sticks. We'll keep welding with it. You can see how the color of the arc is changing as this tungsten becomes more contaminated. And so here now we got our tungsten getting contaminated. And you see as I pull off, I haven't pulled off nearly as far. And this arc is doing all kinds of crazy stuff. And so when you dip it, see how you like to have a nice sharp tungsten? That's what happens to it when you dip. It'll round out, it'll pull some of that material, or if you stab it with your filler when you're welding, and it'll ball up on there, and now it can't give you a nice clean arc. That's why you always need to clean it up after you dip it. So we've grasped pedal control and keeping your bead consistent and being able to make a fairly straight-ish line, right? That's a consistent width. Now we're going to start adding filler into this. So we have that base skill started. So right, we're driving a car. We know how to use the clutch. We can get the car moving with just the clutch. Now we're going to add in the gas pedal, right? We're adding one layer at a time. So now what you're going to end up doing, and we've all done it. I know I keep telling you this, but I know how easily people get discouraged when they're trying something new. And this is all part of the process, dude. We've all done it, and I want you to know that and have that confidence so that you can learn how to do this. Because let's be honest, there's two kinds of people in the world. People that can weld and people that wish they can. So, we're going to get our puddle started. We'll have a nice established pedal, preferably with your hood down. But we'll get a nice established puddle started. Then we'll add a little dip to it. Move, add a dip, move, add a dip, move, add a dip. So, got our puddle. We're going to add some filler, move, 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 add some filler, add some filler, add some filler. Let my post flow finish. And there you go. So the other thing I'm going to recommend, because you're going to dip a lot practicing this, is when you buy your tungsten, just buy a pack of tungsten and sharpen the whole pack. That way, when you're in this practicing phase, every time you dip, you can just set that one to the side and grab a fresh tungsten. And then once you've dipped all of them, go sharpen all of them. That way you're not just getting up, sharpen, put it back, get up, sharpen, put it back. It smooths out your thing, and you can spend a lot more consistent time just practicing getting your beads down and not as much time sharpening tungsten. You can just go between practice mode, sharpen tungsten mode, practice mode, sharpen tungsten mode. So let's do a couple more. Got our puddle started. Add a little bit of filler, move, add a little bit of filler, move, add a little bit of filler. And what we're working on here is you're working on keeping your line, or you're keeping your bead a consistent width and trying to get a consistent dab spacing in between them, which mine could be better, but I'm kind of a fast dabber. Like when I'm welding stuff, a lot of the times is I move a little bit. I tend to weld a little bit hotter and a little bit faster. So my dabs a lot of times don't necessarily always look like a dab, 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 dab like that. It'll be kind of more like a ripple as you go through. Neither way is wrong. This way is definitely prettier, and I need to spend more time slowing it down for when I need a nice, real pretty, like Instagram bead, right? So I'm going to clean up a couple more of these. So once you get to where you can make, some half decent, half consistent puddles, you don't need to be Instagram perfect, right? Just to where you can make an inch puddle and you're not dipping it 3 times. Now we can start putting pieces of metal together. So I'm going to prep a couple of these. You don't need to see me grind on metal again, but we're going to prep a couple of these, and we're going to do a butt joint. We're going to put 2 of them together like that, and we'll tack them, and then weld it together. And then we'll also do a fillet joint where we put them on together like that, and then we weld in that seam. Alright, so I reposition this camera. Hopefully it can capture some of this. So for this butt joint, right, where we're going to put these 2 butted up together, we're going to do part of this with filler, and we're going to do part of it without filler. But we cleaned up the top, and we also cleaned up where they're going to contact each other. So that way, because when you're welding this and these are melting together, it's going to pull from that metal in the middle where they meet. So if you have it the other way around, like you clean up the top and it looks good, but you don't clean up the sides, it's going to pull this dirty metal into your weld and cause problems. So, like I was saying, cleanliness. So we'll tack these together first. So you can start, if these fit really tight, you'll be able to start right in the middle and then give it a dab. A lot of times what you need to do is just aim your tungsten just off to the side, get your pedal started, and then you can roll it in. So we're right off to the side, and then roll it over. You can see the heat from that kind of try to pull this other side apart. So we'll squeeze these together and we'll do that same thing in the middle. Start your pedal, pull it over. You can see that just gives you the tiniest little tack to hold them together. You can't always do it without filler. Sometimes you got to do it and add filler, but if you have a good tight fit, 90% of the time, you'll be able to just start on the side, like right next to the joint, and as soon as you see your pedal form, just give it a little bit extra, and then just give it a little nudge over, and it'll join them together. Otherwise, you can start right in the middle. We'll do that right here. We'll start in the middle and just add a little dab. Right in the middle, you can see the edges start melting, and then give her a little dab. And that gives you a fatter tack. So as you can see, as we're putting heat into this, because the heat shrinks your metal, you can see how it's starting to kind of bow this into a V. So as you're welding pieces like this together and you're welding them and you see this V closing up, don't worry about it. It's totally normal for this practicing thing. That's why, like, when you weld onto something, like if you're welding like a plate onto a frame or whatnot, you would tack all around it first, is to lock it in place so that it doesn't start moving with the weld. But for practicing right here, we'll see how much. This is just from a couple little tacks, and this was dead flat to start. So we're gonna weld down along this, and then you can see how much more it pulls it together. See if I can get this where this camera can see. So we'll do with filler first. Got our pedal going. And you see that color change is because I dipped a little bit. So, but you can see, and it's pulling it a little bit more. So let's go clean this up, because even the teacher needs teaching sometimes. So I dip probably a lot more than most people that have been welding as long as I have, but that's because of my eye. It's with the one the way it is, I don't have the greatest depth perception, so it's not always easy for me to tell exactly how high my torch is. So sometimes if I'm focusing a bunch, it'll get just a little bit too close and touch. And you know, that's fine, dude. You can have issues that you need to work through and still do this. So let's continue on. We got our nice, fresh, sharp tungsten. I could have just grabbed one out of that pack, and we'll continue on, and we'll do this all the way to the middle. See if I can get that where the camera can see. Let our post flow finish. You can see I was getting a little wavy there because this was bouncing back and forth because of the rock in it. But there you go. And then we'll do a little bit with no filler. You can see it's wanting to pull apart here, but let's see what we got. And there's with no filler. Hot. So this one, when you do it with no filler, it's called autogenous. So we have one side. Oh, this is the bottom. We got the one side ground. So now we're going to do a fillet joint. So we're going to tack this guy into place. And what? Oh, get over here. So you're going to point your tungsten straight into the corner of that 90 degree where these are coming together. And as you're doing that, so see we're in the corner there, you'll see the puddle, you'll see both of the puddles start forming. Sometimes it'll immediately jump to a puddle right in the corner of that joint. Sometimes you'll see it start doing a little puddle on top and a little puddle on the bottom. And what you can do is just kind of give this a little wiggle and they'll end up falling together. We'll get this one. Do one more in the middle. See if that works. So we're going to fill this up. You're going to point your tungsten right into the middle of that joint. And we're going to weld her up. Got our puddle. So really, that's it to getting started. There's a ton of rabbit holes we can go down from here, right? We can get into other joints, different cup sizes, different materials like aluminum and stainless and titanium and all of that. But the basics to get started, you just need the torch that came with your machine, 1 cup, like a number 7, 8, or 9, somewhere in that ballpark, and a little bit of can-do attitude, and just practice and see how it goes from there. And then once you've kind of practiced a little bit, you'll start getting more of an understanding of what's going on with it, and you'll have a better idea of what to look for, right? You'll notice, like, I can't keep my arc stable, or you can start experimenting with different tapers on your tungsten and growing and learning from there. But the far of just get started, get a bead going, dude, that's all there is to it. Everything beyond that is time and practice. So I hope this was helpful for you. If you want to go down any of those other rabbit holes, we can talk about different cup sizes and what they're for, or the different tungstens, or welding aluminum or stainless. I've never done titanium, but I'm down to learn on camera. Let me know in the comments. I appreciate all of you, and I appreciate you taking the time to spend with me here, and hopefully this was that last little nugget you needed to get you over to the other side and in the go have it at itness. That's not even a word. And the inspire you to go get started with welding. So remember, if you don't start practicing and dipping your tungsten and learning new things, you'll never get finished.